So I'm going to do question 5 on WebAssign 3.9. I've already done it, so I'm just going to do the practice another. I'm just going to go through and do it, and then I'll come back and explain what I did. That should be easier, probably. Let's pull into a dock. Yes. So we know that dc dt is equal to 1 meter per second, and that dA dt equals 0 meters per second. We want okay. Here we go. Cross. We can start plugging in. So 1. And is that right? Yes, cool. All right. So our question is asking, a boat is pulled into a dock by a rope attached to the bow of the boat and passing through a pulley on the dock that is 1 meter higher than the bow of the boat. The rope is pulled in at a rate of 1 meters per second. How fast in meters per second is the boat approaching the dock when it is 7 meters from the dock? So my answer is 1.01, and here's kind of what I did. So first thing I did was I drew a picture. This would be the dock and the pulley would be up here, so I said that A was 1 meter. This is the distance from the dock to the boat, so I labeled that B and said it was 7 meters because that's what it was asking. And then I just did Pythagorean theorem to figure out that C was square root of 50. So we already know that dc d10, that is the rate at which the rope is being pulled in, aka C, is 1 meter per second. And we also know that dA dt is going to be 0 because this A side is not changing in length. That's the height of the dock. So it's the height of where the pulley is. So it's not going to change, and it means the derivative wouldn't change. We want dB dt, so the rate at which B is getting closer and closer to the dock. And we want that when B is equal to 7 meters, hence B equals 7. So we use Pythagorean theorem. I write out the equation, and then we differentiate with respect to time for each one. So 2 drops down, A times that, it's implicit. get the idea. Each one of those has a 2, so I just crossed all those out because they're all going to cancel out anyways. And then after that, I start plugging in. So like this one would be a times dA dt, so 1 times 0, which we said because that was up there. Next part would be 7 because we're looking for b when b equals 7 times dB dt equals square root of 50 because that's what we said that c is equal to times 1 because that's the rate at which the rope's being pulled in. So you simplify some of that out, you're going to get 7 dB dt equals square root 50, divide the 7 over, and it's going to be dB dt equals square root 50 over 7, which is 1.01 meters per second.